Alright, welcome back to the next video for the lab for Chapter 16. And what we're going to be doing finally is creating forecasts. So I'm going to extend these dates down and we're just going to create, I think I wanted to do 7. So 1, 2, 3, 4, 5, 6, 7. Oh, I nailed it on the first try. We're going to create a 7-step ahead forecast. So we're going to use this daily model to try to forecast prices 7 days out. If we want to try 1 day out, we could do that too. But I want to show you how to continue it on. Okay, so our goal is to create forecasted values ahead in this column here. And I want to just highlight these cells in yellow to remind myself that this is not real data, this is forecast data. And remember, the way the model works is for this value here, it's looking back at lagged values of the returns. So I'm going to pull this lagged column back, not back, but forward one place. And then we should be able to use our regression model along with the lagged values to create a forecast. And what's that going to look like? Well, it's going to look exactly like, excuse me while I navigate back to it, it's going to look exactly like this. We're going to use exactly this equation format to create our forecast. So it's going to be equal to intercept plus coefficient on the first lag times the first lag plus coefficient on the second lag times the second lag plus coefficient on the third lag times the third lag. Now this equation should give me a forecasted return for November 9th. Except I noticed that that date is totally wrong. Let me see if this is better. Yes, 15th. Okay. Sorry, you guys probably noticed that while you were watching the video. Alright, so we have this forecasted return based on the previous 3 days' returns. And if we were really confident in this value, we could make a trade based on it. It looks like basically a forecast of 0% change, so it's not that useful a forecast. But you could see how it might be in a different scenario. Okay, now I want to be able to just drag this down. So I'm going to fix these coefficient locations because obviously we don't want these references moving down as we drag the equation down. So I'm going to go back and press F4 to get $signs on the row and column positions for each of the coefficient estimates. And notice it's going to be all the ones that are in column L. So this is 1, this is 1, and this is the last one. Doesn't change this value, but it allows us to just drag this baby down. Okay. And I'm going to re-highlight these cells because that got messed up. Okay, so in a minute we're going to plot our forecasts with the actual values, but I want us to go ahead and get our confidence intervals going because we're going to plot the 95% confidence intervals along with this. So create this little mini column header here, lower 95% CI. CI stands for confidence interval. Upper 95% CI. Okay, so next we're going to do the formula for how we get those boundaries for the 95% confidence interval. And I've basically got them here in 10 and 11. So for the lower bound, what the 95% confidence interval comes out to be is the forecast value plus the inverse of the t-distribution at 0.025, comma df, df stands for degrees of freedom, times the standard error of the regression, which we get from our regression output. Now, what this means is we're going to ask it to go to the 2.5 percentile on a t-distribution and tell us what the t quote-unquote statistic is at this percentile. And then scale that by the standard error of the regression. So this is a little bit easier to explain with a picture. So I've come over here to the statisticshowto.com webpage. They have a nice little figure of a t-distribution with exactly a 95% confidence interval. So what we're doing is we're saying, I want to go to the place on the t-distribution where the area to the left of it is 0.025. So the value that that function is going to return is this lower limit. Okay, back here to the equation. That value along the x-axis is what we're going to get for this number. And this is depicted at, well, the scale is off, but we're going to, the scale is ambiguous, it's not presented. But we're going to scale this t-distribution by multiplying by the standard error of the regression, which will make it big if the standard error is big, smaller if the standard error is smaller. But in any case, we're going to find this location for our lower confidence interval and this location for the upper confidence interval. And that's going to create this 95% confidence region around our forecast. So we're essentially finding the 2.5 percentile of a t-distribution with a standard error that's equal to the standard error of the regression, and we've centered the t-distribution around the forecast value. That's going to be the lower bound of our 95% confidence interval. For the upper confidence interval, we'll just sort of do it for the 95th percentile. Okay, so let's go back to our spreadsheet. And so that formula is equal to the forecast value plus t dot inverse of 0.025, comma, and the degrees of freedom come over here as the degrees of freedom of the residual. So we'll plug that in. And again, that will give us a location on the x-axis of a t-distribution, but we need to scale that t-distribution by the standard error of our regression. And we get our lower 95% confidence interval. The upper is going to be very similar, so I'm going to fix some of these references and drag the formula over. The difference is I'm going to make this plus a minus. And the reason that works is because this is like minus 1 point something on a standard t. If you want to have the one where there's 2.5% in the upper tail, it's just 1 minus that. So we can just make this a minus instead of a plus as we had it here. Okay, and we should be able to drag this down, except I do realize one mistake. We want to be able to drag this forecast value down. So I'm going to delete the $sign next to the numbers. So there's only a $sign next to the C in this reference. I'm going to do it here as well. And this will make us able to drag the formula down and get our confidence interval. Okay, good. I'm going to end the video here. All we have left to do is to plot the series.